Everyone, this is Mr. Gan. Let's look at this question here. This question is on differential equation. It was actually taken from the year 2018 EJC JC2 mid-year exam, right? Paper 2 question 4. Let's look at this. This is a pretty common question. Actually, it's one of the more difficult kind of question to handle in the examination, like in the exam. All right. So we look at the first part. Our tank has a capacity of 100 liters. So I'll suggest most of the time to just draw this out. So this is V equals to 100. So this capacity here, the capacity is 100. I'm not sure whether the number, the amount of water is 100. Right? So let me adjust this part here. So it has a capacity of 100. Capacity of 100 liters. Okay, and then the tank contains 10 liters of water thoroughly mixed with 300 grams, or just 10 liters and 300 grams of salt. So that's one. Salt water with a concentration of 5 grams per liter. So anyway, this shows us that now the mass of salt, I let it be Lm, but I know that actually the mass of salt is given as the amount dissolved in the tank in grams. Okay, so in other words, this is S equals to 300 grams. Okay, that's one. So salt water concentration of 5 grams per liter. So this tells you actually pouring in is 5 grams per liter, means this is ds dt going in. Okay, I'm using S, take note, because questions say that the amount of salt is actually S. All right, and I'm just slowly chop this whole part out. So now then constant rate, this is ds dt. Oh no, this is not ds dt, sorry, this is actually ds dv in. Okay, and it's poured in a concentration rate of 2 liters per minute, which means this is actually dv dt in. Okay, so while the mixture flows out at the constant rate of 1 liter per minute, so that is okay. The mixture flows out at constant rate 1 liter per minute. So in other words, this tells us, I'm going to use another color. So this one dv, this tells us that where dv dt out is 1 liter per minute. Okay, so that's about it. dv dt out. You are asked to show that ds dt is 10 minus st plus 10. So I think that's pretty okay. Just slowly ds dt. So we have salt at 300 grams, tank contains 10 liter per 10 liter of water. So at time t equals to 0, I know that my S is 300 grams and my volume of water is 10 liter. Let's write that down. And going in, going out, so that's okay. We have got salt water concentration ds dv in. So ds dv in is actually 5 grams per liter. ds dv, right? ds dv is 5 grams per liter. And going constant rate is 2 liter per minute. So dv dt in is 2 liter per minute. So that's okay. Then you are told that the water is going out at 1 liter per minute. So dv dt out is 1 liter per minute. I think this is okay. Then the next part is, as you know, the amount of dissolved salt water in the gram, yada, straight at ds. Okay, great. I think we have all the information that is needed to solve this question here. Okay, now let's start. We know that the net dv dt, you see that this rate going in and rate going out is different. So in other words, you have a positive 1 liter per minute in terms of the amount of water. So dv dt lah, right? This is the one. Okay, now let's start off with ds dt first. ds dt net, okay, is obviously equals to ds dt in minus ds dt out lah. Okay, so ds dt in here, ds dt out here. Now dsdt in would just means that we are looking at dsdt in, which is 5 gram per liter times 2 liter. Sorry, you're using chain rule, dsdv times dv dt. Okay, in and out. This dsdt, on the other hand, out would just be dsdv times dv dt out. Okay, at the moment, at time t, just take note that the mass is s, the time is t lah, small t, that's it. So this going in is okay. Going in is basically just 5 times 2, right? dsdv times. Now the one going out is the tricky one. dsdt, on the other hand, is at the dsdv dt here at the time t. Now you realize that there's a time, the volume is a bit tricky. Volume v is actually just 10, because initially there's 10 liter, right? At every unit time, you're adding 1 liter per minute, right? So say at time t equals to 1 minute, you expect the volume to be 10 plus 1, right? Because 1 liter. So if t is 2 minutes, you expect to have v plus 10 plus 1 times 2, right? Every 1 minute, you add 1 liter of water inside. So at time t, the volume would just be plus 1 times t, a function of time. Express your volume in terms of function of time. That is the one that is going out, right? The amount of salt. So in this case here, ds dv, mass is s, dv dt, v is actually 10 plus 1. dv dt out is okay, this is just 1. Alright, so I think that's the one. So once we get that ready, basically we get dsdv, dsdt. So this is dsdt equals to 10 minus s over 10 plus t. So shown. I get it. Alright, got it. So that's one. Now even if you can't show the first one, is fine. You can just proceed to do the second part without the first one. Just remember that. Okay, so I think that's about it. Now the first part, then the second part. This is the first part. The whole first part, man. Second part is basically asking you to show, asking by means of substitution, find s in terms of t. Okay, so find s in terms. So I'm just copying ds dt equals to ds dt equals to ds 10 minus s over t plus 10, right? Then you have got another one, which is q, by the means of substitution, q equals to 10 t plus 10 times s. So I think this is, by substitution, is okay lah. It's not like very cheap, right? So from here, what we're going to do is we reduce this form here, solve s in terms of t lah. So we need to express, our main job here is to express this dq dt in terms of q and t. That's our main job. Okay, our main job here by substitution is to, our goal here is to change dq dt, ds dt into dq dt in terms of q and t. That's the whole goal, right? Basically you want to change it so that you are able to solve it. So I'm just going to solve this part here. So dq dt, using just differentiate with respect to t. So this will be t plus 10. We're just going to use chain rule, right? 10 plus 10 ds dt plus s d, or just 1. That's all, right? Just 1. Product rule. So just make sure your product rule is okay, right? Because yeah, this is your u, this is your v, this is a u, v prime plus v u prime. That's it. So once you get that ready, what you're gonna do is you're just gonna substitute 1 into 2. I think that's about it. So sub 1 into 2. So that's okay. This will be dq dt. Dq dt equals to T plus 10 dSCT, which is 10 minus S T plus 10 plus S. Okay, so solve this. Oh, this is pretty cool. So this is 10 T plus T S plus S. So this is separable form. That's the reason why we know we can solve this. So this is a separable form, right? So 10 T plus 10. Okay, this is a separable form. So from here, we know that 1 over T plus 10 dq is equals to 10 dt, 1 and 1. Is ln T plus 10 equals to 10 T plus C. That's about it. What am I doing? I'm supposed to solve, right? So I'm just going to solve this. Change this back to oh, sorry, what did I do? dq dt. Oh crap, wrong. So anyway, sorry. 1 dq equals to 10. My goodness, I'm so sorry. I'm so tired, man. Okay, let's do this plus 10 dt. This is q equals to 10 bit square plus 10 dt. My bad. Okay, so anything wrong? I think that's not. So we get q, which is what? Q is actually just q is just T plus 10 times S equals to q, set back q, so S, so 10. So this is I could just multiply 10 in if I want to. You could just multiply in. So this is 5t squared plus 100t. So you can actually factorize the 5t out. So this is t plus 20t, I believe. T, I'll just make sure is t plus 10. Oh my goodness, there's a c. This is c here. So I can add a c in later. So yeah, okay. So this part here, when t equals to 0, we were told that S equals to 300, right? So S equals to 300. Find the boundary condition and solve it. Okay, so here what you get is essentially 3000. 3000 would means C is 3000. 3000, yeah, and you get the answer lah. So S is equals to 5t squared plus 100t plus 3000. Let me check my answer, okay? T plus 10. Let me just go through a bit. I think that's about it. Shouldn't be any problem there. Q dt, Q dq dt, dq dt, t plus dsat s1 sub that dq dt inside t. Correct. So I think this is a correct answer. So S, once you've done it already, hence when the concentration will salt in the tank at the point just before it overflows. Okay. Just before it overflows just means that when V equals to 100 liters lah. Okay. So this part here, when V equals 100 liters, we need to find what are the boundary conditions. So that's not too bad. We already know that this is the time that we have. So part 3, what we know is when V equals to 100 liters, we find what's the T. Okay, we need to find what's the T. So basically when T is 100 liters, we have 100 equals to 10 plus T. So the time would take about 90 minutes lah. Okay, so from here, what you need to do is substitute into S. Well, what do you need to find? Find the concentration of salt of the tank at the point. Concentration, concentration. Just take note, concentration just means mass over volume, right? So this part here, I found the S, which is 5 times 90 square plus 100, 90. Just substitute in, I think there's nothing fancy here, 90 plus 10. Okay, so King calculator. What we get here is 525 gram. So hence concentration would be of salt, right? Would just be 525 gram over 1000 liters. I believe it's 1000 liters, right? 100 liters. This is 525 over 100 liters. So this would be 5.25 gram per liter. That's the concentration they're looking at. All right. So that's the concentration. All right. Gram per liters. That's about it. The part 4. Now, once the volume of the salt of a solution reaches 100, the pouring stops. The tank is allowed to drain off. The salt solution drains from the tank at the rate proportional to the volume of solution in the tank. Let V denote the volume of solution in the tank at time t after it drains off. If the tank takes 10 minutes to drain half, okay, great. So I think this is another question altogether. Let me copy and paste because I think I need more space. Yeah, so paste. Okay, so once you get that ready, basically now in the tank, anything that goes in cuts off. So you could see that this is actually just cut off. Means you cut this off, no longer going in. All right, there's only thing going out, so that's all right. So let's look at how do we solve that. We have the volume of salt solution tank reaches 100 liters. Pouring stop, drain off. The solution drains from the tank at the rate proportional to the volume of solution in the tank. So this is V lah. Volume is V. All right, so dx dt going out. This dv dt is going out at the rate proportional to V. Okay, the source drains off the rate proportional to volume. Okay, V denote the volume of solution in the tank at time t after the tank starts to drain off. It takes 10 minutes to drain half of its contents. So find V in terms of t. I think that's okay. V equals to t time t, V in terms of t. So let's look at how do we solve this. So the big T here is basically denoting that we are, what do you call it? The big T here is basically denoting the time at time t. So time is big T. So dv dt is proportional, is equals to dv dt in minus out. So this is obvious. Actually, what you need to know is dv dt is equals to minus k dv dt out. That's about it. Sorry, dv dt out is proportional to V, right? So this is V. Okay, so once you get that, this is fine. I think it's nothing interesting here. So when t equals to 10, you know that V equals to big, so V equals to V naught over 2 lah. So that's all right. So when t equals to 0, so given that t equals to 0, we know that V is equals to V naught at the start. And when t equals to 10 minutes, V is equals to V naught over 2 lah. These are the boundary conditions. So just know that there's no need to worry about the concentration of salt because it's evenly mixed out and it's not involved in this case. So what we're gonna get is dv integral of dk 1 dt. Okay, so this will be ln V equals to minus kt plus c. So V equals to plus minus e minus kt plus c, and this is my a e minus kt, where my a is equals to plus minus e c. Okay, so when t equals to 0, we just go in the boundary condition. We know that V equals to V naught now, so we know that V naught equals to A. Okay, so when t equals to 10 minutes, V equals to V naught over 2. So this case here, we have V naught over 2 equals to V naught A, which is V naught, E minus 10k lah. So in other words, A is V naught, right? We found out just now. This over here. We get this over here. Okay, so what we get is actually just half equals to E minus 10k. So that's all right. We have ln half equals to minus 10k. So this would be k will just be 1 over 10 ln half. Now this minus 1 could be brought up to the power, so this will just be 1 over 10 ln 2 lah. So that's okay. Okay, so that's about it. Oh, so you add up this one here where k is a positive constant. Okay, it has to be positive because this is a negative, it's going down the rate. Find v in terms of t. So there you go, I got this in hands. V is equals to, what's v naught? V naught, a is v naught, right? Oh, v naught is 100, so sorry, v naught is 100, so v naught is 100 liters, 100 e minus kt, minus 10 kt, so it's just minus ln 2 e, what's the formula? Here is the formula. E a is 100 e minus 1 over 10 ln 2 big T. Sorry, the big T is not a small t. I'm so used to getting the small t. So it's dt lah. T is big T. That's about it. Okay, that's how you solve it. So my t, and I should use the big T lah. Any question or comments? Please let us know. Let me know. Text me, alright, or ask me after class. Okay, thank you very much.